Hi guys, welcome back to the channel. Today we're going to have a look at this. It's a 1986 2204 JCM800. It's the horizontal input model. All right, so around about 85, give or take, Marshall changed these, right? So the vertical input model, which are kind of the more revered of the JCM800s, moved to these horizontal mount, right? And what's the difference? Well, we're going to explore that today. There is a difference between the two. It's not just in the construction method. The construction method is different, right? So they moved from both PCB based, but with from 85 onwards with the horizontal inputs, these things moved to pot mounted PCB as opposed to a chassis mount PCB with panel mounted pots, right? So, but that's not really where the change is from a circuit and tone perspective. These things have different filtering set up and a different voltage supply set up through the preamp. We're going to explore that today, and I'm going to work on this amp and I'm going to modify it back to original vertical input spec. We're going to do a tone test, right, before and after. So the stock 86 setup compared to this amp configured with, let's call it a 1980 spec, right, the earlier 2204. Then we'll have a look at the insides of the amp. We'll go through and measure some voltages and look at the key differences there between the mid to late 80s 2204s and the earlier ones. And we'll finish off with a bit of a look at the theory as to why voltages in a preamp actually do make a difference. Stick around. So a couple of things to point out, right? This is obviously the horizontal mount 2204. The PCB is mounted on the pots, right? So it's only held into the chassis by the pots, which are screwed in, obviously, to the chassis here. I don't know if you can quite see it, I'll show a photo, but these chassis were drilled for 4-hole configuration. So it's just the faceplate that's covering those, the two spare holes for the jacks on the front panel here. Now, the first thing I want to talk about is this amp looks completely stock with one exception. and it's really bizarre. The input here, right? So someone's put a shielded cable on this, which is, you know, not a bad idea, but I've been looking at this thing, and I got the meter out and I checked it and I double checked it, and I've never seen anything like it. Right? What someone has done here is they've connected the ground shield on the coax. Right, so here's the grid of V1A. They've connected the shield of the coax to the plate of V1A. Right, so this is where your guitar signal comes in, right, from your input jack, and it hits the first gain stage here. This is the grid, this is the cathode. So rather than grounding that shield, someone's connected it to the plate of V1A, which is, I haven't measured the voltage here yet, right, but it's going to be well in excess of 200 volts DC. Probably one of the weirdest things I've ever seen opening an amp up. So I'll definitely fix that up, put it back to original spec. Right, so apart from that, everything else looks pretty stock. Now, what I want to talk about is the difference in the filtering and the B plus line, right? So they, with these horizontal mount era 2204s, they kept all the filter caps the same, but they did change the configuration, right? So what you've got here is the first dropping resistor here is 10k resistor. Okay, so we've got 100 microfarad on the mains here. Okay, and then we go through the choke, and the screen supply filter is also these 250s bridged together 100. Right, so that's different than the early 80s 2204s, which had 50 there. And then we go through this 10k resistor dropper, and all of the phase inverter supply, right, for V3, and the supply for V2, which is a third gain stage and the cathode follower, or that way, third gain stage and cathode follower, are all off the same supply as the phase inverter. Now that's different than the early 80s 2204s, right? So you would have another 10k dropper between phase inverter and V2, and then from V2 to V1 we do go through this 10k dropper here, right? So the filtering is, this is bridge for the mains, this is bridge for the screens. This one's split 250s, one for the phase inverter and third gain stage cathode follower, and the other side for V1, the preamp. Now, because there's only one dropping resistor here, we don't have one between the phase inverter and V2. What we end up with is a much higher voltage on V1, right? So the preamp in these are running at quite a lot higher voltage than the early 80s 2204s. Now, part of this clip, right, we're going to do a tone test, because I've captured sounds of this as is, and I'm going to make very rudimentary mods to this to put it to the exact early 80s spec, right? Everything else on this is the same kind of components. The transformers are great. These filter caps look in good condition. I'm going to drop the preamp voltage back to what it would have been in an early 80s, or what it is in an early 80s 2204. Insert the additional dropping resistor and split the filtering, so we end up with a filter cap on each of the nodes, and then we'll recheck it with the same loop that I recorded for the stock test. Let's see if we can make this thing sound a bit sweeter. Right, so I've got the amp powered up now, just running into an 8 ohm resistive load. The master is on 0. Let's take some voltage readings of this beast, right? So let's have a look at plate voltage, and I'll do this by right on the pin. 457, let's call it 457 on plates. That's all cool. Let's try screen. Alright, I'm measuring this on the power tube, 451. Okay, well let's call it 452. Right, which should be 452. Well, that's the voltage there before it hits through the 1Ks here. So if I measure on this pin, 456, right? This 10K. So the other side of this 10K is phase inverter supply node, 374. Right, and as I mentioned, phase inverter and V2 is coming off that single node, and this is the other 10K. So 474, and on the other side, 360. That's the supply node to the preamp, right, to V1. Very high. Right, so we are going to set this to early 80s spec, and I'd expect that to be a lot lower. So if I look at the supply on the plate of V1A here, 267 and 320, right? Pretty high. All right, let's get into it. We're going to have a quick look at a couple of schematics here to demonstrate the difference between the mid-80s and beyond 2204 JCM800s and the generation that preceded it. Just looking at the B+, right? So we're not going to look at the whole schematic. I just want to look at the supply line, which is, really the topic of this video. Your power comes in here. This switch, this is your power switch, right? This is the power transformer. Okay. Now, these secondaries here, red and red, this is your high voltage AC supply coming from the PT. It's your standby switch. Okay. Then when your amp comes out of standby, you're supplying this high voltage AC. These diodes here rectify that and convert it into a high voltage DC. Right. Here are the first can cap. So if you reference to the pictures, that first can capacitor is 250 microfarad capacitors bridged together, creates 100 microfarad through the fuse, through the choke. Now, here's the second can cap, which in this 86 spec 2204, as you've seen in the pictures, right? 250s parallel together. So this is the filter cap for the screen supply, right? So this is the the mains supply here. This is a screen supply through the drop-in resistor. That's the only 10K that there is here. And then this is the supply for the phase inverter. Okay, and then note this point X. Move to the next. Now we're looking at the preamp. So here's point X, right? No more drop-in resistors here. So this is the third gain stage, V2, and the cathode follower, V2B, the V2A and V2B, are tied to the same supply as the phase inverter, right? Then we've got the last can cap, which is not bridged together, right? So these are separate. And we have got one on this side through the 10K and then onto the other. Now I have moved over here to an earlier schematic, right? You can see this is 1981. This schematic was drawn. So this is the both the 50 and 100 setup for 2204 and 2203. We're looking at the power section here. Now, the first thing I want to point out is in these first generation 800s, a 50 watt had a much lower B+. So look at it, 365 volts screen supply node, right? Which means that the mains, probably only a couple of volts greater than that. Whereas in the 100, we've got 470 here. We go 367, there it is. 470 and 468 on the screens. Now, the supply voltages in my 50 watt 2204 that we're looking at here from 1986, it's this level, or close to it, right? So Marshall definitely in this, the mid-80s and beyond generation of the 2204, 2203s, or 2204 circuit, I should say, standardized the supply voltage between the 50 and 100. So there's two reasons why the voltage supply in the preamp in the mid-80s and beyond 2204 is so much higher than the earlier ones. A, they've got a much higher supply voltage, and B, there's less drop-in resistors through the preamp. So if we look at the 100 watt, because this is what I'm basically dealing with, right, with this, 86 2204, I've got a B plus of, was it 450 odd volts, right? So it's much closer to what's going on in the 100 watt than it is in the 50. So after the screen supply, two 10K drop-in resistors before we get to the phase inverter, okay? Which is exactly why when I made my change, I'm going with two 10s in that those first drop-in resistors. Into the preamp, let's have a look at the master volume preamp. This is the one at the top here is for the 87 1959. That's the 4-hole plexi style pre. So this is our 2203, 2204 style preamp here, and you can see. So this is point A from where we were. We'd just come through two 10K droppers, right, and a filter cap on the supply here. This is the phase inverter supply. Then there's a 10K before we then go into the third gain stage and cathode follower supply. And you'll remember from the 86 schematic that we just looked at, this doesn't exist. The phase inverter supply is tied directly to this supply. Okay, so here we've got that extra 10K, and then there's the filter cap for it, 10K again, and then the last filter cap for the supply to the preamp. Right, all the changes are in. I'll just step through them and we'll take some voltage readings. Now, remember what I'm trying to do here is get reconfigured the power supply all the way through the amp to be the same as the original 2203, 2204s, early 80s or even late 70s JMP spec. So I've split this was the screen supply filter cap and it was bridged across as 100 microfarad, right? So I've split that and I'm using one side of it for screens, so 50 microfarad screen filter cap now. The other 50 is this new red wire is going into the other side of this drop-in resistor here. So this is now the phase inverter filter cap, and I've inserted another 10K 2 watt drop-in resistor here, so 20K dropping here from the screen supply node to the phase inverter supply. And down here in the preamp, I had to make a few changes to get this to work without any drilling or anything. But yeah, so all these mods completely reversible actually if you wanted to move it back to 86 spec. So I thought about it, come up with a few different ways to do it. I'm pretty pleased with this method because, as I said, it's absolutely no damage to the amp whatsoever. Everything I've done here actually is entirely reversible if you needed to. So there's the 100K, so on the third gain stage and cathode follower, I've moved this 100K resistor here, was on the board, which was forcing the supply node for V2 to be tied to the PI, the phase inverter supply. So I pulled that out and then mounted it on the tube socket, just like they used to be, right? And now the supply for the cathode follower, rather than this red wire here, rather than going onto the board, it comes across to this filter cap here. And this red wire here is coming off the supply line. So this is the phase inverter supply. It runs all the way along here on a PCB track. Comes off the board here, this red wire, makes its way here. This is a 10K, another 10K 2-watt resistor just under the heat shrink. Right, so I'm getting a 10K dropper onto this node, which I'm running V2 off, which is exactly what I want. And then this 10K dropper here was on the board. It was also on the PCB. I've taken that off and mounted it directly to the can cap as a 10K dropper between this V2 supply node and V1 supply. Okay, so exactly as we wanted it for in the early 80s, 2203, 2204. So this red wire here, which is existing, comes back onto the board here. This is where the 10K, that larger 10K dropping resistor used to be here, now on here. Comes back on the board and sets up the supply node for the rest of the preamp. So let's check some voltages. So let's just go through the main supply nodes, okay, because I'll be checking them off against the Marshall spec. All right, so let's look at the main supply node. 4.5, let's call it 453, close enough. Screen supply is this side, 451. Phase inverter, 3, 2, 1. Okay, supply node for V2, cathode follower, well, third gain stage and cathode follower, 283, and for the preamp V1, 273. Let's have a look at the voltage on V1A. Always just check that, right? Right, bang on 200. Okay. V2B, 241. Okay, well, I'm pretty happy with those. I was looking for phase inverter supply of somewhere between 300 and 330. That was my target. Right, so I'm on 320. So right in the middle, well, close enough. I'm really looking forward to what this amp sounds like now. So I think we'll bring it back into the studio, plug it in, and we'll put that loop that I've already recorded sitting there. We'll play the loop back through. Same settings on the amp. Let's see how we go. So why does a lower voltage on a triode, or the preamp of this 2204, why does it make a difference? Well, I'm going to look at load lines again, guys. I'm saying again because I featured this in the previous video where we looked at the difference that the value of a plate resistor makes on a gain stage. Now, obviously in both these scenarios here, the higher voltage and then the lower voltage configuration, we're using the same plate resistor, right? 100K, the 100K all the way through on the the first two gain stages on a 2204. So the gradient of the two lines are the same. This in the red here is the load line for the higher voltage setup, the 86 spec, my stock amp, and the blue is the load line once I drop the voltage to early 80s spec, right? So the node voltage for the preamp before I made the changes was 360 volts, okay? And then after I made the change, the node voltage was 273 volts here. And you can look at the last video to see how you draw the load lines, right? So I've just drawn these in. So you just have to take my word for it, but it's pretty simple to do this. Have a look at the previous video. Now what I've drawn here, you can see three lines down here. What I'm trying to demonstrate is what's happening at a bias point. So let's imagine that this grid voltage here of -2, imagine that's the bias point. In other words, that's kind of, if the grid is steady state and there was no signal coming in, no guitar signal coming into the gain stage, this is where the operating point is. Now, what I'm demonstrating here is what happens with a grid voltage swing of 1 volt either side. Right, so if that's our operating point, then a swing of plus 1 volt brings us up here, or minus 1 volt brings us down here, and then a corresponding change in our amplification. So this is what's going on in terms of the actual amplification. Again, consult the previous video for information about kind of reading these load lines. The blue is the same thing. So -2, imagine that's our bias point, our operating point at idle, and then a voltage swing one way and then the other. Now, two things happen. Two things happen here at a lower voltage that will change the shape of the wave of the amplification stage. Okay, when we're operating at a higher voltage here, these grid lines, they're steeper and they're more kind of even, right? You can see the grid lines here. As we go down the graph, they get flatter, but also closer together. So if we look at the operating point to the right-hand side here, the distance from the middle bias point to the right is shorter than from the bias point to the left, right? Which means you're not going to get an equal amplification on either side. In fact, moving to the right, it's going to be more squashed. If we look at what's happening with the amplification, it means that one side of the ground point will be elongated compared to the other. The closer you are to operating at grid levels on the right-hand side of the graph. Now you can see with the lower voltage, we're really starting to get into much flatter curves here. Right? So here it's nice and steep, and down here it's much flatter, right? So you're getting a more pronounced asymmetric wave here when you're operating at lower voltage. This is pleasing to the ear, right? Because you're introducing harmonic distortion here by the mere fact that you've just dropped the voltage. The other thing that happens is you're approaching the cutoff point, right? So on the load line here, as we approach what was 273 volts, the valve will go into cutoff, and if it goes to cutoff, you'll get square wave. Right? So at our operating point here in the early 80s spec, a voltage swing of 1 volt either way on the grid, it's starting to bring us very close to cutoff. Right? So you can imagine if this was the second gain stage and it's been hit by the output of the first gain stage, you can easily push this valve into cutoff much sooner than you can here on the higher voltage. This is why with lower voltage on your triodes, you get more compression, more asymmetric harmonic distortion, and generally it's just more fun to play. Right? So you get this kind of thing where I've kind of crudely drawn this on the sine wave here. Imagine this is your output of your amplification stage. Then up here is what you'd be getting when you're operating at the higher voltage, and like that when you're operating at the lower voltage. This is now an absolute killer 800, right? So now that it's set to original 80s spec, you know, the first generation 2204s, absolutely love it. I actually picked this amp up as a trade-in on one of our Cali amps. My intention was always just to, you know, give it a once-over, a service, and list it and recoup the funds. But now that I've converted this back to, you know, original first generation 2204 spec, I don't know if I can part with it. I just love it. It's like everything I want in a JCM800 2204. It just sounds awesome. It's great to play. The only thing we probably need to do is put an SD1 in front of it. So it would be rude not to, wouldn't it?